Problems of quadratics. A lot of times you're looking at finding a couple of different things. You're looking at finding maybe a 0. You might be looking at a maximum value or a minimum value. And since we haven't done a lot of the physical graphing quite yet, what I want to do today is kind of walk you through how you can find these things via your calculator. Now, the word problems we're working on here are going to be mixtures from 5-1 or 5-2, 3, 5, and 6. I don't think the word problems in 5-4 really aren't that good. But they all kind of blend the same. There's not a lot of trickery, if you will, within these things. And one of the ones I want to start with is in 5-2, and kind of walk you through what this looks like. This is right out of your book in section 5-2 on page, let's see, what is this? 259. And I'm going to walk you through how they set it up and what exactly does it mean as it's going through it. Let's see, you have a music-oriented website that allows subscribing customers to download audio and video clips of their favorite bands. When the subscription price is $16 a year, you get 30,000 subscribers. For each $1 increase in price, you expect to lose 1,000 subscribers. How much did you charge to maximize your revenue? Okay. What is your maximum revenue? So let's take a look at how this is. First of all, this is 1989 or 1992. Obviously, it's only $16 a month for unlimited downloads. You guys don't pay anything for that anymore. When was the last time you bought a CD? Yeah.
I don't think I've ever bought a CD.
Really?
I don't buy CDs.
Think about it. I can't remember last time I basically bought a compact disc. I like that too. But it's just, I can't remember last time I'll download it, that type of thing. They physically go to a store and purchase these things. Now records, I'm about to buy old records, so that's cool. So here's what we're doing. What it wants you to do is, let me ask you that. If you're having something that's going to be a maximum, and these are quadratics, we all agree that quadratics are curves, right? They're up like a cup or down like a frown. Remember that vaguely? So if this is going to have a maximum, is this quadratic going to be up like a cup or down like a frown?
Up. Down.
It'll be down like a frown.
No. It was just the way he said it. Because he said up like a cup when he was doing it down. I'm not confused by that.
This is down like a frown. This is up like a cup.
Yeah, that's what it backwards.
Did I say it backwards? Is that what it?
Yeah, I didn't think there was a frown.
Anyway.
That looks more like a smile.
Anyway, in this case, if I'm talking about something having a maximum value, will it be up like a cup or down like a frown for the quadratic curve?
Down like a frown.
It'll be down like a frown. It's counterintuitive of what you want it to be. Down like a frown makes you sad, but yet it has a maximum value. There's a maximum value here. There's a maximum height. There's a minimum height. Okay? Depending upon the quadratic. With that being said, do you guys remember from your algebra classes what makes a quadratic positive or up like a cup or down like a frown besides the positive or negative? What's positive or negative? What is it?
Can you repeat the questions?
The question. What makes a quadratic? How can you tell when looking at a quadratic function if it's going to be up like a cup or down like a frown? Okay, what's negative and what's positive?
Isn't it
First term, the x squared term. Yeah. Basically, it tells you that in a quadratic, you have ax squared. If a is positive, other way around.
What?
If A is positive, it's up like a cup. Okay.
The A is negative.
If A is negative, it's down like a frown. I know you guys have seen that before. I know you guys have done that before. It just might, the verbiage of me how I'm discussing it might be a little different. So back to this problem here. When we're looking at this one here, the dead giveaway of one of the words was maximum. So that means what's your curve going to look like? It's going to go like that, right? It's going to look like this. Now, what's that? If I go back to what info they've given me, it tells me the subscription price is 16 bucks a year and you get 30,000 subscribers. For each $1 increase, you lose 1,000. Now, do you agree that those are two parts of the problem? Two terms, if you will. Okay. So if you're looking at two terms, could one of them, let me move, I really don't need to have all this here right now. Oh, let's do this. It's quicker. So one of the terms is $16, and the other term is going to be 30,000. Everybody okay with that? Okay. What am I doing in this model, in this problem, to the $16?
Increasing.
I'm adding, increasing. For every dollar I increase, I lose 1,000 subscribers. So I'm adding X here, and what am I subtracting on the other one?
1,000.
1,000X. Oops, sorry, that's 100.
Oh.
That value of X is the increase. So if you increase $2, you're losing 2,000. If you increase $5, you're losing 5,000. Does that make sense?
Yeah.
So now, has this created its own quadratic model?
Yeah.
So here's what we want to do. I know that this is going to equal 0. I know that I can find my zeros relatively easy. -16 and something. Do you agree on that? Okay. The question here becomes is, how do you find a maximum value? Or how do you find a minimum value? This is where I'm going to show you how to do that in your calculator. Because a lot of times with these, you wind up with some funky values that are tough to factor through and go. So, let's see if this will work today. Yay! Here's what I want you to do. Go to your y equals, and we're going to type it in exactly the way we saw it. Leave it in parentheses. You don't have to FOIL anything out. Calculator's smart enough. Parentheses 16 plus x. Close it. Open the other one. It's 30,000, I believe.
Yeah.
Minus 1,000 x. And close the parentheses. Go to your graph. You're right. You don't see it. But let's think about what you know. What's one of the zeros? It was at -16, right? If you go back and look at it, if I'm looking at this, I know that one of my zeros will be at -16. You agree?
Yes.
All right. Oops. If I go the other way around, I know that my other zero would be at what? 30?
Yeah.
Everybody okay with that?
Yes.
Do you, I'm just finding my zeros. I know that this graph is going to look like this. Here's -16, here's 30. It's going to cross the x-axis there and there. Okay? Yeah, yes, sir?
How did you figure out the -16, 30 thing?
I set those both equal to 0. I just found the zeros. Okay?
Okay, well, I get the 16 one, but why is the 30 though?
I add the 1,000
Oh,
x
you
divide out
divide it,
5,000.
got it.
Okay? So I know that it's going to look like that. I also know that it's something like this. So somewhere between those two values, what's going to have to occur? The maximum value. So let me show you how you can play around. You guys ever played around with the window yet on your calculator? Kind of change the screen size? Okay. Hit the button that says window. More often than not, your windows are probably set at a 10 by 10 screen size. Well, if we are looking at something that we already know that our zeros are going to take place outside that window, let's change it. Let's make our x minimum value, negative 20. Okay. Let's make our x maximum 35. We know it's at 30, but that way we can look beyond it. Okay, what about the y? Do I care what the minimum values is at y?
No.
No. Can I just make it, just leave it at like -1, just for example? Or let's just leave it at -10. It doesn't hurt any. But we know that the maximum value is going to be somewhere in between there. So just to visualize it, let's change the y value to 100. I don't know where it is, but we'll just see if we can find it. Okay? And now hit graph and see if your curve shows up. Sort of. We know that maximum value is even further up there then, right?
Yeah.
Can you change it again?
Yes.
We're changing the y max, right?
Changing the y maximum.
We're going 100,000, let's go.
Try 500. Oh, I hit 5 by mistake.
Gotta go higher.
Let's go to the
I'm going 530,000, let's go.
500. Sure.
I found it.
5,000.
530,000.
10,000 didn't work.
530,000 was it.
530,000. Well, that's just crazy.
I went up to 500.
Well, I see it. Trial, man. Earlier, so I found it. The maximum was already.
Oh, there it is.
Okay.
And the maximum is.
If you have an invalid dome or domain, that just means something. You might have flipped a sign. Oh, really?
Easy win.
I don't know why it's doing that. Well, if you do that, the other thing you can do is now you see it visually, so we know that that maximum value had to occur somewhere in there. So we're going to figure out where that somewhere is. No, that takes too long. Second, calculate. What's there an option of?
Maximum.
What do you think we're going to use? Now here's where it gets interesting.
Oh my God. Value.
It's okay. I hit second, calculate. Now, this is where it gets interesting. You got to pay close attention to where your boundaries are set. Right now, it's asking me the question for the left boundary. It's at 7.5. My cursor's kind of blinking way up there right now, but I don't know if that is correct. So I'm going to kind of move it to the left a little bit. So it's kind of off the top of that curve. Okay?
Not bad, how much?
I just hit it like 3 or 4 times to go to the left of the top of the curve. It's going to be tough to see it because this curve, because your height is so way up there. I've got another one we'll do here in a minute, be a little bit easier to calculate with. So now what I'm going to do is hit enter. And now it asks me right bound. But one thing real fast, does everybody see this little arrow that's showed up on your screen?
Yes.
Okay, that means it put a boundary line there. What it's doing, what the calculator is going to do is that it's going to search between this boundary and the next boundary we find for the biggest value that it has.
How do we get to the right now?
It automatically, as soon as you hit enter, it's asking you right boundary. So now you want to move it to the right of the peak of the curve. So hit the button 4 or 5 times more to go that way. And hit. Now there's another arrow.
Yes.
And now it says yes. Potatoes.
Correct.
Sweet. Get sweet potatoes.
Yeah. I get it.
And hit enter one more time. Your maximum value is at the ordered pair of 7 and 529,000.
Yeah. Yep.
After you hit where it says, does your screen say guess? Have you picked the boundary on the left?
Yeah, it's like, can we get like more big numbers, like millions? Can we get a million?
No, but you just care about the value.
You want to need to see your peak standard, or you want to know the peak. See how it starts to come back down, like, now hit enter. Now move to the right. That's good. Hit enter. Hit enter one more time. Okay. All right. So what this is telling us is a couple of things. They're telling us, according to our calculator, that the maximum value is occurring at 7 and what was that? 529?
Yeah.
00? Thank you. Okay. So think about what it's asking you now. What is the value of X that maximizes the revenue? 7. And how much money do you make? That's how you model the quadratic. You increase it $7. So it'd be $23 a year. Okay. So what the calculator is allowing you to be able to do is find that value quickly without having to go through the whole rigmarole of trying to factor and go through a whole bunch of junk. Okay? That's why modeling with the calculator is really, really nice. Being able to use that maximum or minimum value on a calculator screen.
So if that was on a test, we would write down like the original, like 16 plus X, but then basically the answer, and then put like calculator.
Yeah. Because to be honest with you, a lot of times when if I'm using a calculator to solve a problem, you're gonna need to model it a little bit. You'll have to get some sort of a funky response for it. Let me show you another one similar to that without a crazy curve. Okay. Let's see. Let's say I have the following. Just go right to your calculator. Oops. I'm going to go to, do you guys know how to reset this then?
Yeah.
Okay. Go back to your window and change that all back to 10 by 10. Negative 10, 10. Yeah, and just hit enter. And then once you get everything back to like 10 by 10s, you just go right back to your y equals screen and it's not a big deal. Okay? I know for a fact that in some of the science classes, depending upon what you guys are doing, sometimes they will, if you guys are using the graphic calculators, they'll turn on and off your grids. The x and y axis may not be there. You might plot things a little bit differently. Don't freak out. It's very easy to fix. They do it a lot, okay? You'll be messing with your windows a lot when we do some modeling stuff, okay? So here's what I want to look at. I'm just going to take a regular old boring quadratic equation and type it in the calculator and show you what it does. 12x squared minus 25x. And then I think it was plus something. Nope, minus 7. Now, this is one of those trinomials that we would factor, find zeros, and all that kind of fun stuff. Let me show you what the calculator would be able to do with this. I go to the graph. Well, we know it's up. It's up like a cup because that first term was positive, correct?
Yeah.
So it's up like a cup. And I also know that my lowest point, the minimum value, is below my screen. So there's two ways to find it. First way, you tilt it. You might.
Wait, is she actually doing it?
Oh my God.
No.
Yes, every year.
No, you didn't.
Awesome. That was so awesome.
You did not really do it.
I'm sorry.
Gosh, she's just like.
Alright, that's the biggest blonde moment I've ever seen.
I'm sorry.
It's okay, keep all of it in there.
Anyway, I'm sorry. All right, so go to your window. And in this case, for us to see that lower value, are we going to change the y maximum, y minimum? What are we going to change?
Y minimum.
All right, change your y minimum. Make it negative 30. I don't know where it is. We're just going to try to take a quick guess.
20.
$300.
I put it at 20.
go back to my graph. Everybody see it? Okay. Really?
You just made that.
12x. And then minus 7. Just reset it. I don't know. There might have been something sorted in there that was funky. If it does that again, I'll show you how to reset it. Hey guys, it's a great thing that just happened. If your calculators keep coming up with errors, a lot of times what's happening is that there might be something stored in there from a while ago that is no relation to the problem you're working on. So that moment is when you do the achoo and reboot the calculator. To reboot the calculator to make sure everything goes back to normal, you just do the following keystrokes. Second, plus sign, 712, enter. And then you do second, plus sign, 722, enter. And you should be good to go. What that does is it resets everything. It resets all the memory, it clears everything out, so that way if there was anything that was stored through that was like some error message that comes up, like the invalid dim, that's a very common one. If you can't figure out what's going on, reset it. Usually what happens if that is, there's like a bad sign somewhere in your window. That's usually what it is, but you can't find it, just reset. It's quicker than anything. Yep, you just do those two in sequence. It takes 3 seconds. It doesn't take long on the calculator. So again, if I want to find the minimum value, this will be easier for you guys to see with those cursors with the left and right bounds now. We hit second, calculate. Now instead of choosing maximum, isn't one, we choose the minimum. And notice how this time my cursor's blinking at 0. Yep. What I'm going to do is just move it down a little bit so it's a little bit closer. So I'm going to move it to the right. And I'm still to the left of the lowest point. Does everybody see that?
Yeah.
I hit enter. That little arrow comes up. I move it around the curve. And I hit enter again. Guess. Tuesday. To be honest with you, I have no idea why it says guess. I have no clue. I've never understood why they have to
I
guess.
want you to guess where
It's a game.
It's a game,
I
yes.
got it right.
And then your minimum, in this case, it occurs at a decimal value, okay? The reason this is a decimal value is because your zeros are all funky. They're not nice integers, so your export is going to be nice. So I'm just trying to show you how you use that to find it through, okay? Yes, ma'am. We're not doing that today. But the modeling, the reasons why, the question was, can we do this without a calculator? Absolutely. Opposite of b over 2a gives you your x value, substitute that back in, and there's your y value. But when the modeling stuff comes into play with the word problems, they're always crummy values, and it's much easier to see. That's why we do it. Okay? Questions? The problems I'm going to have you guys do, like I said, is a bit of a mixture between the last few sections, and they're very straightforward. Whether you're looking to find a 0, which means you factor something through, solve for 0, or you might be finding a maximum or a minimum value. So let's see, this is section 5.2. Forgot what number this page number this was on.
259.
The word problem, though, it starts on 262.
And I remember now.
I didn't remember that.
The 5.5 is on page
297.
287. Oops. Oh, I'm ready. So we have 287. And then the section 5.6 is that last group.
Oh, what? Oh.
You're killing me.
296.
Oh.
Okay. The mixture of these things are really straightforward. The 5.2 ones kind of have that idea of a dollar increase here, you lose somebody there. The 287 first grouping are using some geometry formulas. So you're using the geometry formulas in resolving to maximize your area. Guess you're setting an equal to it. And then the last grouping is using the quadratics. And you're just kind of writing out the solutions there. Now, what I would suggest that you do when you're dealing with some of these quadratic problems, especially like in that 5.6, is to draw a diagram of what's going on. If you draw a diagram of what's going on, it's much easier to interpret what you're going to do. Okay? Questions about that? Yes, ma'am.
On the website, like on the school website, when we try to find the school website, we have the list of all of these.
Yeah. Yeah, have you not done that yet?
No, I have.
Yeah, you can do fonts, or one that, yeah.
The what? Oh yeah, don't use the algebra book. Don't use that. What you want to use is, the algebra 2 book is awful.
Okay.
Yeah, you don't want to use the algebra 2 book because that's just bad. So if are you going to just directly to here?
Yeah.
Okay. When you get to here, all you're doing is hitting this tab up top. And that's where all your sections are. There's all your sections.
Well, that's disappointing.
You just click on it. There it is.
God dang it.
Are you using the book website? You're using useful links where it says book website? Did you not see where I say this site is horrible, don't use it?
So what? Maybe.
Oh, I can't read very well. Oh well. See you guys, have a good one.